Hey guys, so there is something new we're going to do today. It is called linear inequalities. The reason we're going to move on to something is because this is technically just a step up from something that we already know. So first of all, the word linear is line. We know how to draw lines. We can draw lines using y equals mx plus b. We can draw lines using ax plus by equals c. You do not have to take notes on this. You can if you want to, but I'm not going to require it for you to bring it back with you. We will put notes on this in our journals when we get back. So just kind of watch the video. Just take notes mentally. Besides that, you don't really need to take notes. So anyways, we know how to draw lines. We could even use point slope form, which isn't a very used, it's not used often, but it's used. Anyways, sometimes these lines don't have equal signs. They have inequality symbols. Inequality symbols look like this: the less than or equal to, greater than or equal to, less than or greater than signs. When you have a linear inequality, you don't just have the line that you're equal to. You have a line and something. So this is what I mean by that. If we had a graph like this, I'm just going to pretend that I draw my x and y axis, and I'm going to change my color pen to like that. And let's say that we had y equals, oh, I thought I changed my color. There we go. And let's say we have y equals 1x plus 2. Okay, I just made up that, by the way. So remember, 2 would be our y-intercept, and if our slope was 1, that just means up 1 over 1, like this. And I can also go down backwards if I wanted to. And that would be the line, right? It would be equals because it's literally that line. However, if we ever changed it to something besides an equal sign and we made it to an inequality symbol like this one, less than or equal to, I'm going to say just less than. Less than. So if we have an inequality saying it's less than, y is less than 1x plus 2, we don't have equals, which means our answer technically isn't the line, it's less than the line. So if we have less than the line, our answer is actually all of this stuff down here, less than the line, below the line, right? Does that make sense? The other thing about this is since it does not equal the line, it actually doesn't equal the line. So instead of drawing a red line like this, I should have drawn a dashed line like this, not a straight up line, a dashed line, to show that it is not exactly equal to this line, but basically that's like our border, and everything underneath it is what this equals. So we took a linear expression or a linear function and we changed it into something that does not exactly equal. It's the line. We knew how to draw it. However, it's either going to be greater than or less than. So if it was greater than, we would have done it above the line, which is kind of like all the y values are bigger, right? So I would have shaded on the top. If we ever had less than or equal to, technically that does mean that we can equal the line, like we can equal the exact line. If we had the less than symbol, that meant that we could get really close to the line, but we can't exactly equal the line, right? But if we have less than or equal to, we do have this line, and I would have just drawn a solid line in like normal, and then found somewhere to shade. So with that being said, let's look at some examples together in IXL because this is what you're going to be working on today. So you took notes mentally, and then you are going to find a way to graph. So I did this one already on accident. But anyways, the IXL code is HHP. I'll make sure to say that later, HHP. It is graphing linear inequalities. So this linear function was x equals -1. They changed the equal sign to an inequality sign, but we're going to consider it x equals while I graph. Okay, so first of all, x equals -1 is here on the x-axis. That's -1. And if we need to draw a line that is specifically x equals -1, I will not draw it this way. That would be the x-axis, which is x equals all numbers. But if I only wanted specifically -1 for x, I would have to go up and down. I could put my dot wherever I wanted to, because no matter where I do it, the x value for that coordinate is -1. Okay, so we just drew the line x is equal to -1. Now remember, I said you had two things to remember. One is where to shade, and the other is, do you have a dotted line or a solid line? So as a quick reminder, inequalities that look like this get a dashed line, dashed, dotted, whatever. If you have inequalities that look like this, the or equals to, technically means that you do not need to draw the dotted line. It's not smaller than or bigger than, it's also equal to. All right, so we have a dashed line, which means that, or we have a let or greater than symbol, which means that we need, excuse me, we need a line that is dashed. So if you hover over the line, you will start to have little dashed options. So just click the dash and it turns into a dashed line instead. If you ever do that on accident and you hover back and it gives you like a solid line, you can change it back to a solid, okay? Then you have this little spotlight looking thing. It is going to ask you where to shade. So let's think about this critically. X is greater than -1. Pretty simple. If x is greater than -1, it's not these numbers over here. Those are less than -1. It would be these numbers here. X is greater than -1. So I click over there, it shades it. If I forget and I did something wrong, if I click again, it would unshade it. Anyways, that is our solution. We press whatever and it says good work. So let's try another one. Not exactly the x equals thing. It keeps giving me those options. All right, so we have a normal y equals mx plus b line. This would have said y equals 2x plus 3. So I'm going to go graph y equals 2x plus 3. So first is the plus 3. That would go about here, right? That is the y-intercept. I put a dot. My slope says 2, so that means up 2 over 1. Up 2 to the right 1, always to the right. Remember, if you ever went to the left, you now have a negative slope, and that is not what we have up there. We have a positive 2. All right, so I drew my line. Now I have to think, is it solid or is it dotted? Let's figure it out. We have a greater than or equal to. Since we have the or equal to, we leave it as a solid line. We do not need to change it to the dashed. Remember that I'm going to make a quick little note to myself over here in my little notes that if we have a greater than, oh, that's not what I meant to do. If we have greater than or equal to, but no, if we have greater than or less than, it is dashed. If we have greater than or equal to, it's solid. Quick little note, just so I can go back to look at it here in a second. Let's go back here. So now this is going to be a little bit trickier. Remember, the x was kind of easy because it was like a number line. However, this one is y is greater than 2x plus 3. If the y value is greater, that means that these numbers on the y-axis is bigger than where we're at. So if we're bigger, we're on top of the line, we're up here. Okay, you kind of have to think on top or below of the line. Okay, so that is our answer. Let's try it. Let's try another one. Do another one together. So, this one is in ax plus by equals c. So this one's going to take a little bit of work. So let's try it. If we have ax plus by equals c, that's a, that's b, that's c. Remember to find our x-intercept. we do C over A. So I have 14 over 1. 14 over 1 is 14. I don't have 14 on my graph, so I'm going to move on. I can't actually graph my x-intercept. It's too far off the graph. My y-intercept is C over B, which is 14 over 2. I'm doing it with my fingers, so just, try to look at this stuff. It's kind of difficult. 14 over 2 is 7. So I have a y-intercept. It's 7. I'm going to put a dot here. Okay, well, there we go. Actually drew it now. Remember, whenever you do one dot, you'll be able to start graphing the next dot. So don't click anywhere again until you're ready to do the next dot. So the slope is the last thing that we know from ax plus by equals c, and it is what's going to help us. I'm sorry this is a long video, but it's a lot to show you guys. So I'm going to use my pen. The slope is negative a over b. And if we have a 1 in the a spot, I do a negative 1 over b, which is 2, positive 2. So that means I have a negative 1/2 as a slope. So I go here, and I go, back to the original dot that I was at, go down 1 over 2. Remember, it's to the right 2. And that's my line. So I have my line. Now I'm going to figure out if it's dashed or solid. I have that's a less than or equal to symbol, but honestly what matters is the fact that the or equal to is there. If the or equal to is there, you have a solid line. If it's not, if it's just greater than, just less than, that means you don't have a solid line, you have a dashed. Right now, we have a solid line. So I do not need to press that dash thing. I just need to figure out where to shade. This is where it gets a little tricky. When you have ax plus by equals c, you have to use a point to try to figure out where it's going to work. This is what I mean. I'm going to go back to Google Keep real quick and show you. Oh, that's not what I need. So if I have ax plus by equals c, and over here it was x plus 2y equals 14. It was actually like that, right? Let's just check. Yes, that is what it said. Okay. If we ever tested a coordinate, as in the origin is probably the easiest, right? It's 0, 0. If I put 0, 0 in for, no, I'm going to go back here. If I put 0, 0 in, like this, started to use, I'm going to use, oh, stop it. 0 plus 2 times 0. Why did I put zeros in the x and the y? Because it's the coordinate. And then let's evaluate this. Let's see if it works. Let's see if 0, 0 really does fit into that equation. So 0 plus 2 times 0 would be 0 plus 0. All right. And then 0 plus 0 is 0. Is 0 less than or equal to 14? Yes, it is. Since the origin worked inside of that equation, since it worked, 0, 0 is in the part that is shaded. Okay. Testing the origin can work for regular y equals mx plus b if you're having trouble where to shade. So let's go ahead and submit this. I'm going to clear my screen. I don't know. Oh, there it goes. And then I'm going to try another one with you guys. One more. I know this is a long video, but I really wanted you to get to understand what's happening. Perfect. Another ax plus by equals c. It'll help us. All right. Wonderful. All right, so the x-intercept is 16 over 9. 16 over 9 is a decimal. I'm going to skip it. I'm going to move on to the y-intercept. The y-intercept is c over b, so 16 over negative 4. We do consider that minus 4 a negative 4. 16 over negative 4 is 4. Oh, no, it's negative 4. So my y-intercept is negative 4. And then I have to find my slope because my x-intercept didn't work. So I'm going to use my pen again. My slope is a negative a over b. So I have a negative 9 over negative 4, which is just positive 9 over 4. So whenever I go to my dot that I just made, I go from the dot up 9. 1, 2, 3, 4, 5, 6, 7, 8, 9 over 4. 1, 2, 3, 4. Create a dot. Do I have a solid or a dotted line? I have a solid line because of that right there. That tells me it is a solid line because of the or equal to. Solid or equal to. So I do not need to press this because that would have changed it to a dash. All right. Now let's look to see if I have shading on the top or the bottom. Remember, this is where we have to test the origin. Test the origin. So I'm going to go back to Google Keep. I'm going to write down the stuff that this was again. I think it said, let me just double check. 9x minus 4y. Okay. 9x. 9. Oops. 9. Come on. That's way too big. Oh well. 9x minus 4y, and it has that inequality symbol like this. I think I'm right. Y'all let me know, double check me. Remember, if we test the origin, that is the easiest coordinate. I could test any coordinate I wanted to. I could put 1, 2, or -5, -7, but 0, 0 is much easier to work with. So I'm going to test the origin. I'm going to figure out if the origin is some numbers that work inside of this equation. So let's evaluate. 9 times 0 is 0. 4 times 0 is 0. Okay, let's see if this works. 0 plus 0, obviously 0. You could have probably figured it out before, so is 0 less than or equal to 16? It is. 0 is less than or equal to 16. So whenever I have that works, I will shade below the line. I'm sorry, that is wrong. I will shade where the origin is. So we found the origin. We tested it. The origin worked. I shade where the origin is. Okay, whenever we had the y is greater than or equal to, I did the whole above or below thing. When I had ax plus by equals c, I had to test the origin. Okay, you can still, like I said, test the origin in the y equals mx plus b version too. But the y equals mx plus b version is kind of easier. You could just do above or below the line. You don't really have to do a bunch of math. But when you get to the ax plus by equals c, you do. Okay? I know that was a lot. We're going to work on this today. I don't expect you to get really good at this yet. Obviously, it's difficult. Please refer back to this video. Refer back to what I say about how to do this. I will, make sure you're coming back to this video and watching. And I'll do some more notes tomorrow and we'll do some more practice. But today I really want you to try to get at least an 80 on this IXL assignment. And that is what you have to do today. I will be on Google Meets twice. I'll be on until 10 o'clock and I'll be on until from 1 o'clock to 3 o'clock. So anytime in between there, if you have questions about this, let me know.